12.2 Box and Whisker plots. A box and whisker plot is when data is broken down into 4 parts using 5 numbers. In reality, it's more like 5 parts, but we consider the min and max value to be the same similar parts. And so the first part of a box and whisker plot is your minimum value. The second part is your first quartile or your lower quartile. So this is the point that marks the 25th percentile of your data. So 25% of your data is to the left of this point. And I like to abbreviate this as Q1. Your second quartile or your median is the third piece of information we need. I label this quartile 2 or Q2. And then your fourth point is third quartile or your upper quartile, which marks that 75% of your information is to the left of this point. So this fourth point is quartile 3. And the last one is your maximum value. The interquartile range is the distance between the first and third quartile, or points 2 and 4. And in order to find this, we take quartile 3 minus quartile 1. So in reality, the interquartile piece is the entire large rectangle. And then the last part of this is outliers. And these are values that are much higher or lower than most of the data. And so one thing I want you to take away from this is this large rectangle, your interquartile piece, if it is wide or stretched out, that means that your data is generally very spread out within the bulk of your information. If it's compacted, that means a lot of the data values were collected that were very close together. The same thing with your min and max. If they're stretched out, that means there was a wide range of values that were collected. If your min and max are closer together, the range is much smaller. And then this line here in the box represents your median or your very middle values. So you'll have 50% of the values to the left and 50% of the values to the right from that point. The dot plot below shows the distribution of ages of 80 viewers of a TV show. And so we're going to use this dot plot to create a box and whisker plot. So the first thing I want to do is identify my min and max values. Well, my minimum value would be here. My max values would be here. So I'm going to put a dot above the minimum and a dot above the maximum. And I'm going to connect these points in order to start my box and whisker plot. The next step would be to find my median. Well, there are 80 viewers, so half of 80 is 40. So that means I need to go through 40 data points, and then between the 40 and 41st data point, we will find our median value. So from the left, we count over 40 dots. And as we count over, we reach that the 40th dot is there and the 41st dot is here. So our median, or quartile 2 in this case, is right around 60. Then we know that quartile 1 represents the 25th percentile, or 1/4 of our data should be on the left of it. So 1/4 of 80 is 20. So to find quartile 1, we count 20 dots from the left. And we get that this dot here represents the 20th dot, and we're going to look between the 20th and the 21st dot to find our quartile 1. So this is quartile 1, and it has a value of 40. When you're cutting an even number in parts, if you like 80, we cut 80 in half, we got 40, so we look between 40 and 41. It's just a good indicator of where to look. So when we cut 80 into a fourth, or we could have said cut 40 in half, we got 20, so we look between 20 and 21 to find those values. For quartile 3, we're looking for the 75th percentile. So 75% or 3/4 of 80 is 60. So we'll have to count over 60 places, or 60 values. So you'll count over 60 points from the left, or you could count over 20 from the right. And when you do this, you reach that your 60th point would be there, and your 61st point would be here. So that means quartile 3 falls right around 70. So now that we know our min, max, and our quartiles, we can go ahead and place our values on our line here to create our box and whisker plot. So we put a die at quartile 2, or the median, a die at quartile 3, which is our upper quartile, and then a die at quartile 1, which is our lower quartile. And now we just create our boxes. All right, and so as we create this box, remember, we have a max value, we have our min value, this value is our median, and here we have quartile 1 and quartile 3. All right, and so the next question says, what is the inner quartile range? Well, to find the inner quartile range, you're looking for the difference between quartile 3 and quartile 1. So quartile 3 is 70, quartile 1 is 40, so our range, or inner quartile range, is 30. That means there are 30 ages between the quartile 1 and quartile 3. Not 30 individual people, but instead there are 30 possible ages that could take place. "30 female users and 25 male users were selected and given a test of their leadership. A score of 1 to 40 is considered a beginning level leadership score. A score of 41 to 60 is considered middle level leadership score, and a score greater than 60 is considered an advanced level leadership score. We want to take this information and create 2 separate box and whisker plots to compare male and female scores. We'll start by identifying the pieces we need from the female scores. So for females, we know that the minimum value or minimum score was 10. We know that the maximum score from the chart was 76. The next step is I'm going to find quartile 2, or the median. Well, if there are 30 scores, halfway between 30 is 15, so we're looking between values 15 and 16 to find our median. And as I count, I figure out that this is the location of our median, which is between 65 and 65, so quartile 2 is 65. Next thing I want to find is quartile 1. Well, quartile 1 is 1/4 of the way, so in this case, 25% of 30 would be 7.5. So we're going to look at data value 8. And so we count over 8 units, and we get that quartile 1 is 40. From there, we're going to look for quartile 3. So if we counted 8 units over to find 25%, we could count 8 units back to find 75%. So 1, 2, 3, 4, 5, 6, 7, 8. So quartile 3 is at 76. Now we're going to take this information and create our box and whisker plots for female scores. So our minimum is 10. Max is about 76. We will connect the points. We've got our quartile 1 score of 40, our median score of 65, and our quartile 3 is the same as our max. So this is the female box and whisker plot. Now we'll do the same thing for the males. We'll calculate the min, the max, and all 3 quartiles. So the minimum for males is 15. The maximum value for males is 50. There are 25 data points here. So to find the median, we're just looking for the middle of 25, which would be the 13th value, which in this case would be 30. So the median is 30. To find quartile 1, we're going to figure out what 25% of 25 is, and we're going to count there. So in this case, half of 25 is 12.5, which gets us the 13th value. Halfway between the median and the starting point would be essentially 6 values, so you count over 6, and then it's between the 6th and 7th year, so we've got 25. So quartile 1 is 25. And then we'll do the same thing to get quartile 3. We'll work our way backwards though. So we'll count over 6, and it's between the 6th and 7th back, which in this case quartile 3 would be 40. So now for the males, we have all the information we need to create its box and whisker plot. So its minimum is at 15, max is at 50, quartile 3 at 40, median at 30, and lower quartile at 25. All right, so we have our box and whisker plots. The top one being female, the bottom one being the box plot for the males. And so the next part it asks, what are some of the differences between the male and female scores? And there are a lot of different things you could come up with here. You should notice that the female scores have the greater range. They also have the greater IQR, or interquartile range. Females have the the higher median. And if you think about it here, this portion of the male box plot represents 75% of its overall data. Well, 75% of the male scores are below 75% of the female scores. So what that means is 75% of the females outscored the majority of the males. What else you should notice is that the male box and whisker plot is less spread out. So most of its scores were more closely compacted, where the females have a much larger range, meaning they scored all over the place for the most part for a lot of their points. You'll also notice that if this represents our median, you'd be pretty wise to guess that this actual data distribution is left skewed, because that's our median, but there's a lot of points pulling the rest of this box plot back to the left. So that means our mean is probably back this direction somewhere. Consider a box plot of the ages of 200 randomly selected people from Kenya. For definition reasons, let's put some dots here. And so in reality, what we'd have here, what we would call these on a box plot would be outliers. So add those to your notes. All right, so the first question says, what percentage of people are between 0 and 18-ish years old? Well, if you think about it, this line here represents our median. And our median tells us that 50% of our data is this direction, while 50% of our data points are this direction. So that means there's 100 people to the left of this, regardless of how this picture looks. This little box and line here represent 100 people, because box and whisker plots illustrate concentration, not necessarily quantity. So what percentage of people are between 0 and 18? Well, based on the box and whisker plot, 50% of the people are, because our median hits at 18. And so with that information, which has more people in it, under 18 or over 18? Well, we just said that under 18, there's 50% of the people going this way, and then over 18 would be the other 50%. So both groups have 100 people in them. So our answer here is they have the same amount.